You're asked to find the solutions of an equation in the interval of 0 to 2 pi. So 0 is part of the solution, 2 pi is just a boundary. And you're given an equation where the angle, in this case the angle theta, is multiplied by a constant, and in this case it's multiplied by 3. Okay? And then you're asked to write your answer in terms of pi. If there is more than one solution, separate them with commas. Okay, so just a quick reminder, you need to be familiar with the 45, 45, 90-degree triangle. And remember, we're going to think of this as the sides x and y would be 1, and the r value would be the square root of 2. And when you have that case where x or y is 1 and r would be the square root of 2, that's a pi over 4 degree reference triangle. And then you're also going to have this 30, 60, 90 degree triangle that you need to be familiar with. Opposite the 30-degree angle is the 1, the hypotenuse is the 2, and the square root of 3 is the side opposite the 60-degree angle. Now we're talking about radians, so remember 60 degrees is bigger than 30 degrees, right? So if I took something and divided it by 6, that's going to be smaller than taking the same value and dividing it by 3. That's going to be a bigger piece of it. Okay, so pi over 6 goes with the 30 degrees and pi over 3 goes with 60. Now you also need to remember your intervals in radians. So 90 degrees is pi over 2, this is pi, 3 pi over 2, and then back up here to 2 pi. R, remember R is always going to be positive. If r equals 1, then you're not going to have a reference triangle, but you're going to have you're going to just kind of sketch a little picture on one of these intervals. You know, either 0, 2 pi, pi over 2, pi, 3 pi over 2. Okay, I have an example for that one, so you'll see as we go along the second example will relate to that. So let's go ahead and solve this question. Now, when I solve this, the first thing I need to do is get sine of 3 theta by itself. So I'm going to subtract the square root of 2, and then I'm going to divide everything by 2. So you're going to end up with sine of 3 theta equals a negative square root of 2 over 2. Okay, that's from subtracting this and dividing by this. All right, now I want to this denominator looks like it's been rationalized, square root of 2 over 2. Now you may already recognize it. When I see that, I think, hey, that's a 45, 45, 90-degree triangle. But if you don't recognize it, what you're going to want to do is multiply both sides by square root of 2. Anytime these numbers, like you have a square root of 2 and a 2 down here, or a square root of 3 is up here and there's a 3 down here, there might be some other things up here too. But then you want to unrationalize it, so you do it the same way as when you would rationalize it. So you multiply it by the square root of 2 over 2. That gives you a negative 1 over, negative 2, I'm jumping ahead, over 2 times the square root of 2. These simplify and gives me a negative 1 over square root of 2. Okay, the easiest thing is to recognize, but if you don't recognize it, you can go back to this. And I remember that sine, in terms of x, y, and r, sine is y over r. Okay, so then I'm going to kind of sketch the values from 0 to 2 pi that gives me a y value of a negative 1 and an r value of square root of 2. So I want to look for my reference triangles. And so y is negative in quadrants. Let's see, y's are negative when you go down here, so that's in quadrant 3 and quadrant 4. So I'm going to draw reference triangles. In quadrant 3 and 4. And I can see here that y is a negative 1 and my r value is the square root of 2. Okay. So I have these two reference triangles. Now, hopefully at this point, if you didn't recognize it already, then you're recognizing, hey, that's got to be a 1 square root of 2 triangle, which is a 45-degree angle, or pi over 4 radians. So this reference, they're both pi over 4. So now what we want to do is look at what are these angles? So what is this angle here? And then what is this all the way around to here? So then what we're going to do is we need to say, okay, this first angle here is going to be pi plus pi over 4. Okay? So remember, pi we can think of as 4 pi over 4, and so that gives me 5 pi over 4. So what we're going to say is 3 theta, one of the possible solutions is 5 pi over 4. I'm going to say comma. And then I'm going to do this all the way around here to get to this one. What I'm going to do is, this is 2 pi, I'm going to take 2 pi and I'm going to subtract pi over 4. Now if you take that, you can multiply 2 pi by 4 over 4, and that gives me 8 pi over 4, which simplifies to 7 pi over 4. Okay, so I'm going to put that down as one of my possible solutions. Now I probably should have done this first for you so you could see the interval that, you know, do I keep going? And because this is 3 theta, what I want you to realize is your answer, what you're looking for is theta. And we want theta to be in between 0 and 2 pi. But I need to multiply everything here by 3 because I am finding out what 3 theta is first. So if I go through and I just multiply everything by 3, okay, this is going to give me 0 is less than or equal to 3 theta, which is less than 6 pi. So what I want you to think about what 6 pi is, because all the way around would be 2 pi, all the way around one more time would be 4 pi, and all the way around one more time would be 6 pi. So we want anything less than that 6 pi in our solution set here. So basically, what I can do is I want to find out if I went all the way around, remember that would be 2 pi, plus back to this angle again. That would give me another solution. So what I'm going to do is basically add 2 pi to this value. So since the denominator is 4, I'm going to multiply this by 4 over 4, so that gives me 8 pi over 4. And so that's going to give me 13 pi over 4. Now we can do the same thing for this 7 pi over 4, because if we went all the way around my unit circle, plus all the way back to this reference angle again, that would be 2 pi plus 7 pi over 4. So again, I'm thinking of that as 8 pi over 4 instead of 2 pi, so I can have a common denominator. And so that's going to give me 15 pi over 4. Now I want you to see if I went 2 rotations around, okay, and then back to this reference angle, that's still less than 3 rotations. So you can get that by by adding 2 pi on to this value here. Let's see. I'm going to unit up all my colors here. Just do. So if I add 2 pi to this one and 2 pi to this one, it's going to give me my next 2 values. Because again, if I add 2 pi to this one, that's all the way around twice, plus all the way around to this reference angle again. Okay, so basically I'm adding 8 pi over 4 to this value and 8 pi over 4 to this value. So 8 pi plus 13 pi, so 8 and 13, that is 21 pi over 4. And then if I add 8 pi over 4 to 15 pi over 4, that's going to give me 23 pi over 4. Now this is what 3 theta would equal. So what I want you to think about is if I had 3x equals some value, so just look at these two right here, how would I solve that? So if I just had 3 theta equal to 5 pi over 4, and I asked you to solve this for theta, I would multiply both sides by, or divide both sides by 3, right? And what I want you to remember is when you're dividing by 3, that's the same as multiplying it by 1/3. I have to start writing a little smaller here. So this gives me theta equals 5 pi over 4 times 1/3, which gives me 5 pi over 12. Okay, so that's what this value is. So basically I'm going to do the same thing to each of these values. I'm going to divide each value by 3, essentially. I'm going to multiply each of these values by 1/3. So that's going to give me theta equals, if I multiply this by 1/3, remember I get 5 pi over 12, comma, so I'll write a little higher on that one. And then this one is, when I multiply this by 1/3, I get 7 pi over 12. Okay, and then this one I multiply by 1/3, that gives me 13 pi over 12. And then this one, when I multiply by 1/3, I'm going to have, of course, the 15 pi over 12, but that's going to simplify. I can divide both of those by 3, and that'll give me 5 pi over 4. And then this one, again, it will also simplify. When I multiply this, I get 21 pi over 12, and I can divide both of these by 3, and that gives me 7 pi over 4. And this one gives me 23 pi over 12. Okay, so those are 12s except for these two that are 4s underneath there. Sorry, I got a little squish there. Okay, and that's your answer for theta. Okay, so let me show you a couple other examples. Okay, see if that helps make this a little more clear for you if you're still feeling a little unsure about what we're doing here. Okay, so here's another problem. Now, the first thing I want to do is get sine of 3x over 2 to be by itself. And again, the interval here was 0 to 2 pi as well. It's always going to be 0 to 2 pi, and that would be x. So x is going to be in between 0 and 2 pi. Why don't we just take care of that right away, to kind of get an idea of what you're going to do. Now remember, what I'm going to do is, this is 3 over 2 times x, so I'm going to multiply everything by 3 over 2. Okay, so now what this gives me is 0 is less than or equal to 3/2 x, which is less than, I simplify this to 3 pi. I want you to think about what 3 pi is, what we're talking about here. This would be all the way around would be 2 pi, and all the way over here would be 3 pi. So we're talking about a rotation and a half. So we're going to look for, I want you to give me any of the solutions for this that fall in that range. So let's see what we have here first. Okay, so here we're going to subtract 1 from both sides. Okay, now in this case, I want you to think of sine in terms of x, y, and r. Sine is y over r. Now r is always positive, so this negative has to go with the y value, and I can write it as a fraction, as a -1 over 1. So my y value needs to be a -1, and my r value is 1. Anytime r is the same as, is 1 unit, and y is 1 unit, or x is 1 unit, then what you have is a point that's on one of these intervals. So I want you to think about y would only be negative if I'm going down, okay? And if y and r are the same distance, they're both 1 unit, this negative is a location. Think of this negative as a location, so it's going down, okay? But the length is still the same. They're both 1. Okay, so my solution is going to be a point on this line. And so what is that angle? The angle, okay, is 3 pi over 2. So what I have here is 3x over 2 equals, 3x over 2 comes from my equation here, 3 pi over 2. Now what I want you to realize is if I rotated all the way around and then rotated back to 3 pi over 2, that's more than 1.5 rotations. So I don't need to count that interval. So it's not in between here. Okay? If I was doing just 3 theta, then I'd be rotating around all the way around and back to this value again and figuring out what that would be. Okay? And I'd go around one more time. So I'd be doing the 2 times around and then return to here. And I'd need to calculate both of those. But I'm not. I'm just doing 3x over 2. So I'm looking at this interval here. So now I need to solve this interval. So I can solve this by multiplying both sides by 2 over 3. And so that gives me x equals pi. And you're only going to have one solution for this one. Okay, so let's look at one more. And in this one I have the square root of 3 times the cosecant of 2x minus 2 equals 0. Again, for the interval of 0 to 2 pi. So remember 0 to 2 pi, that means that x is going to be in between 0 and 2 pi, not including 2 pi. That's a pi, pretend. Okay. And then I'm going to multiply, since this is 2x, I'm going to multiply everything here by 2. And so that's going to give me 0 is less than or equal to 2x, which is less than or equal to, or less than 4 pi. Okay, so what that means is anything less than 2 rotations around, because this would be 2 pi plus one more time around would be 4 pi. Okay? So let's solve this. We're going to first add 2 to both sides. And then divide both sides by the square root of 3. Okay, then we need to think cosecant is the reciprocal of sine. Sine is y over r, so cosecant would be r over y. Okay? So this is my r value. My r value is 2, and my y value is the square root of 3. So my y value is positive. So I need to think, where are my y values positive in these 4 quadrants? Well, y's are positive when you're going up, so I'm looking at quadrant 1 and quadrant 2. So I'm going to draw reference triangles there. Now remember, sometimes you're looking in terms of x, so these just examples that I gave you just happen to all relate to the y value. Okay? So if x is negative, you might have your x is negative going to the left here, so you would draw reference triangles in quadrant 2 and quadrant 3 here. Okay? Alright, so my r value is 2. My y value, this is y, square root of 3. So this is where if you don't recognize which triangle we're talking about here, you need to go look back at your picture. This is going to be a 30, 60, 90 degree triangle. If this is a square root of 3, this is my 1 value, and it would be a negative 1 here. Okay, and so opposite the 1 is the 30 degree angle, so opposite the square root of 3 is the 60 degree angle. So my reference triangle here is my pi over 3. So these are both pi over 3. So I'm looking for 2x. 2x is going to be, so if I want to find this angle here all the way around to here, I'm going to take pi, and I'm going to subtract my reference angle, pi over 3. Okay, so think of pi as 3 pi over 3, and that gives me 2 pi over 3. Oops, I should have started with this first one right here. So I'm going to say my first one is just pi over 3. And then my next one would be 2 pi over 3. Sorry, I got a little ahead of myself there. Now, remember, I want to look at the solutions less than 4 pi. So I want to think if I went all the way around and then back up here to this reference side right here, to get this angle, I'd say that's pi plus pi over 3. Okay, so think of that as 3 pi over 3, that's 4 pi over 3. Okay, so I'm essentially adding 2 pi to this. And I can do the same thing here, find out what if I went all the way around and back to this reference triangle, I'd be adding 2 pi to 2 pi over 3. Okay, and so that's going to be 3 pi plus 2 pi is 5 pi over 3. 5 pi over 3 is still less than 4 pi. Okay. Now, if I tried to go around 2 times and back to this one, you'll find that it's going to be bigger than 4 pi. It's not in that interval. Okay? So if I tried to add 2 pi to this, that would give me 7 pi over 3. Okay? So, okay, so it's going to be too big. So now I have these equations. Now I need to solve this for x. So remember, if I just had, I'll write this over here, if I had 2x equals pi over 3, that's this part of this interval, I could solve that by dividing both sides by 2 or multiplying both sides by 1/2. And that gives me x equals pi over 6. Okay? And you need to do the same thing to all 3 of these. So you're going to get x equals pi over 6. If I times this one by 1/2, the 2's will cancel here and leaves me with pi over 3. I multiplied by this one by 1/2. The 2 and the 4 can simplify. That gives me 2 pi over 3. And I multiply this by 1/2, and that gives me 5 pi over 6. And all of these intervals are in between 0 and 2 pi. Now, one of the things you might have noticed is a pattern. If this was 2x, usually you're going to have 4 answers. Okay, the exception is when my solution is at one of my intervals here. Okay, and if I have 3x, usually I'm going to have the 6 answers. If I had 4x, I would have 8 answers. Okay, kind of get the pattern here. Now, when you have half angles, you know, you might have 1 or 2 answers depending on the intervals.